Okay, so first we want to install the add-on. Go to Edit, Preferences, Add-ons, click this little arrow here, Install from Disk, go and find the zipped file and install the add-on. Once that's done, you should have a panel like this on the side. You've got a number of different options here. You can either use the eyedropper tool and select an object you want as your target. And if we generate cameras, it's just going to be taking the origin of this object and using it as a parent. Or failing that, you can get rid of this, create a target empty, and generate cameras. And essentially, it will be doing the same thing. Sometimes this is helpful if you just want to reposition things and not start messing around with pivot points. The radius will change how far away the cameras are from your target. The number of cameras, you can crank this up, but this is not dynamic. So say we want to set this to 200 cameras, generate again. The focal length, this will change the focal length for all of your cameras simultaneously, but you will need to regenerate the cameras. So it's applied to all of them. The same goes for jitter. So as the info box says, random offset to break spiral regularity, 0 equals perfect spiral. I normally don't touch this. You can change this if you want, and it will create a little bit more randomness in the generation. I normally find that 0 is a good value. And then the display size, this is pretty helpful. This is dynamic. So sometimes your cameras are getting in the way, or there's just so many there. Append mode does exactly that. So say you've done a render, you've done 100 frames, and now you realize you actually want some more angles. Click append 100 cameras. You can keep adding more or less as you need. We'll just delete these for the moment. The last setting is Frustum Coverage, which we will go over later. That will make more sense. So that's if you want a spherical setup. So in camera mode, if we change this to proxy surface, this is slightly different. Let's say you have an object that's a bit more of an obscure shape, an L shape or something that's long. We'll just use this lamp for now. We've got the camera mode set to proxy surface, and now it's asking what's the proxy object. So I'll just build that really quick. So now we have a proxy object. We'll select this cube and then generate cameras. If we go into X-ray mode, turn the display size down, and we'll just hide this proxy object for now. As you can see, it's using the cube's normals to distribute the cameras. So what I often like to do is, if we unhide this, and we just add a little bit of geometry to this box, I generally find that a capsule shape is good for this. So if we regenerate the cameras and then hide this, as you can see, you've got a little bit more of a circular or spherical pattern going on. It seems to do a better job of distributing these cameras. Talking of distribution, you probably want to keep it on this setting. If you change it to random and generate again, as you can see, it is quite literally random. It's not very evenly spread out. So I generally keep it on this, especially if you're going to be appending cameras. It just keeps a nice even distribution for your object. Surface offset is essentially what radius is for the sphere target setting. So if we go into one of these cameras, you can kind of find a sweet spot until you're happy with how far away the cameras are from your target object. And then for the render settings, self-explanatory, but which frame do you want to capture? This is useful if you've got a scene that has, I don't know, lots of animation and you want a specific frame. Bear in mind, at the moment, this is just a 3D Gaussian splatting system. This can only capture one frame in time. I might be releasing a 4-dimensional Gaussian splat add-on where we can work with some animation, but for now it's just one frame. So here, just select the folder that you want to go with. So I've got my demo folder, click accept. I would normally keep the name capture as is. That's the name of the folder that will be created, and all of the files will sit inside that. As the info box suggests, this is the pose information for all of the cameras in the scene. You will want to keep this checked for your project. Skip already rendered does exactly that. So let's say you have a crash, you're rendering overnight, and you wake up in the morning and you just want to click render again. This will skip, as it suggests, already rendered frames. Or if you're trying to chunk this out and render this over like a few days, it just means that you don't have to worry about cameras starting again from, zero. It's gonna have a look at your project folder, see what's already been rendered, and then go from there. Start from index essentially just forces SplatWorks to render from a specific camera as the info box suggests. So say 134, it will start at camera number 134 and it will render everything from that point. And then when you're happy, just hit render all cameras. This will open up the render view as you would normally expect. Some of the other add-ons that I've tried seem to just freeze up your whole machine. I didn't like that. So you still have the regular functionality that you would have inside Blender while these are rendering out. So if we go to the working space that I mentioned earlier, the capture folder, you've got all of your images, as you can see, that are being rendered out right now. You've got your capture info. This essentially is just a record. So if you come back to this at a later date, you can see exactly how many cameras were in the scene, the focal length you were working with, the proxy object, how far away you were from your target, what sort of distribution you were working with, or if you were going to hand this off to another artist, they will know exactly what settings you used, what frame range, the resolution, number of samples, file extension, what frame number. You've got all of this captured. As well as that, you've got all of the camera's transforms, so the poses. This just contains each camera, where it is in the world, what's the orientation, etc. So the final section is the sparse point cloud. So as a subject, you can choose selected objects, a collection, or visible in render. There are use cases for all of them. Let's just go with selected objects for now. So we'll select our object. We'll just keep the point cloud at 50,000 for the moment. The bounds. We're not working with a camera sphere. We're working with a custom mesh. We can just choose our proxy geo that we set up earlier. It's basically just capturing any geometry that sits inside this. The color, it will actually capture the material base color for the objects that you're working with, or you can set it to off. It's not overly important. I normally would try and capture the material base color. And then here you have a checkbox for output Y is up. So this just means that your point cloud is the correct orientation and isn't on its side like this. So keep that checked, then select preview in viewport. As you can see, this covered our entire object in these little points. You can change this on the fly. So if we say maybe 10,000, preview this again. When you're happy with your results, just click generate sparse PLY. As you can see, now you have a PLY file, and essentially we're going to feed this, your camera transforms, and all of the renders into your training software. This final box, write col map sparse /o/. This is just creating the relevant files that would be used with something like colmap. If we open this up, different software wants to be fed a slightly different format. So for things like PostShot, this isn't necessary, but for other software, as the info box suggests, Nerve Studio, colmap, things like that, it would expect to see files like this as well as your renders. So if we just go back to the sparse point cloud settings and delete our preview. Earlier I said that you could choose a number of different ways of telling Blender what you're trying to generate a sparse point cloud from. So we can choose collection, and in this case it would be our street lamp collection. And now I don't have to have anything selected. It's going to pick every object inside this collection. I would normally use that. Or let's say you've got hundreds of objects. You don't want to mess about with a collection. You can just click visible and render. Obviously, be careful of what's selected, what's visible. If you are doing something like that, you want to be careful with regards to your bounds. So let's say the bounds were set up incorrectly. And it was something like this, right? So SplatWorks, the bounds object is our proxy cube. And we've got our subject, that's fine. And we want to preview this. As you can see, it's using the cube as the object to specify where the point cloud should be. So if we turn this off, the bounds we set to say none, and visible in render. It doesn't matter where this is in the scene, as long as it's visible in the render and it's not something like a camera, it's actual geometry, it will capture exactly what you want. So the last feature I want to go through is check Frustum Coverage. This is just checking whether or not all cameras can see the subject. So as you can see, all 200 cameras see the subject. Let's say we introduce something like a plane and we block some of the cameras. We run it again. It will select those cameras and let us know how many. You can see the system console for more details if you want, but this is normally enough to let you know there's something up with your capture, as this is going to come back with absolutely no information that's relevant in your render. So say we hide the plane, run it again, all good. Same if we were to, let's say, rotate one of these cameras off and run it again. It's picking up the camera that is not seeing anything. And that wraps up everything for this tutorial.